Our talk today will be organized around these 4 themes, and we will draw on work that people across the university have done in this space, and also on discussions we've been having with policymakers and practitioners in the States. So what we'll be presenting is not just our ideas, but a lot of people's ideas. To respond to Young's question, how can Tasmania avoid the problems that the Murray-Darling is presently facing? We'll first highlight a few differences that Tasmania has that give us some advantages as well as some challenges. A very obvious difference is the size of our catchments. They are much smaller. A single catchment of the Murray-Darling, say the Lachlan or the Murrumbidgee, is over 80,000 square kilometers. That's like larger than our state. Our largest catchments, say the Tamar or the Derwent, are no more than 10,000 square kilometers. Now, the large catchments the small catchments rather, give us some advantages. What we do, the solutions can be smaller. We do not have to all negotiations do not have to occur between people living very far apart or across state jurisdictions, for example. It also gives us a few challenges, though. There's a lot of diversity in a very small space. So it requires a lot more effort in terms of planning, in terms of management by a small group of people. We'll just briefly look at the Murray-Darling just to see what we should avoid. If you look at the trajectory of resource development in the Murray-Darling, water use and extraction increased after the wars. It was following a period of really wet conditions, so there was a lot of optimism about water availability, and that influenced the level of extraction that occurred. There were a few economists who objected to that level of investment, but mostly they were ignored. And irrigation development was quite synonymous with nation building, regional development, and agriculture and irrigation became really entrenched in the social fabric of rural Australia. It was only in the 70s and 80s with the environmental movement that there were real challenges, and then had to start the arduous process of water reforms, which involves setting a cap on the diversions, negotiating water sharing between states, and then having to buy back water from irrigators, which is a very complex social challenge. All of us would hear about the Royal Commission right now investigating the Murray-Darling Basin. So controversy and conflict rages on, even though the Basin Plan is heralded as a really big, bold step in policy circles. One key message that stands out for me from studying the whole Basin Plan process is that undoing something is very, very difficult. So as Jacques Leslie points out, the price of taking too much water from the river is to have to give it back later. So coming to Tasmania, the main legislation here is the Water Management Act, which aims to promote sustainable use, facilitate economic development, recognizes social benefits as well as maintain ecological outcomes, promotes collaborative management. So we have the framework in place before we start our major expansion in irrigation. That is an advantage we have over the Murray-Darling. We're also signatories to the National Water Initiative. And all our policies, plans seek to realize these outcomes that are defined by this Act. And there are a lot of players. It's also important to recognize when we think of irrigation in Tasmania that only 20% is actually extracted. This is 2016 data. So only 20% that's extracted from channels and pipes. The rest is from farm dams and directly out of rivers and creeks. So there are many players involved when we speak about irrigation in Tasmania. if we focus on the more recent expansion of schemes here, of course, the rationale is quite similar to what happened in the Murray-Darling, that irrigation enables higher value generation in agriculture, supports regional development. But there are important differences between what the Murray-Darling Basin plan trajectory showed and what we are doing here in Tasmania, perhaps informed by the mistakes we want to avoid. The schemes that we have are much smaller, for one thing, of course dictated by the geography. The schemes are also based on interest expressed by the local community, backed by private commitment for private investment. So economic viability is a key part. Even environmental sustainability is considered in the development of these schemes, including at the farm level. So there are many things we're doing better, I could say. Now, the main rationale for a lot of irrigation rollout or irrigation expansion is that having access to irrigation water allows us to increase value from agriculture. And the agri-growth strategy of the state government has this bold aim of increasing it tenfold, the farm gate value. While this is indeed an ambitious goal, it is not so unrealistic. If you think of the Coal River Valley, Jonathan West, in his report in 2009, pointed out that the land use change that followed the rollout of irrigation in the Coal River Valley actually increased the value produced in that region several-fold, much more than what was anticipated at the time. Another study done at UTAS by John Tisdall and Daniel Worf modeled future climate and land use scenarios in the Midlands region alone and suggested as much as a 20-fold increase in returns is possible by transitioning to new land use. So it is theoretically possible. But one thing we must remember is that irrigation not only transforms land use, but it changes many other things. It could lead to increase in land prices and costs, which can prohibit non-intensive land use. It can also lead to increased corporatization and influx of outside capital, which can lead to social consequences resulting from that concentration of capital and power. There are also invariably some environmental consequences that we will have to contend with. And ultimately, the social license of farming would need to be maintained or could be at risk if you're not proactive about it. Just briefly talk about a PhD project done by Melle Nichols, who's from Wageningen University. He's doing a joint PhD with UTAS, and he's speaking to farmers in the Coal River Valley and asking them what makes them decide to invest in water or not. And he finds that investment decisions are dependent not only on economic possibilities, as we commonly assume, but also the personal circumstances of the individuals, their families, their risk preferences. And once they sign up to an irrigation scheme, all of this changes. Being part of an irrigation scheme influences their daily lives, the lifestyle, the skills they need, and again, their long-term perceptions of risk. In fact, participants in a recent workshop of Melle's predicted that water prices could quadruple in that region. So they almost prepared for that level of increase in price. What could that do to the society there? Sorry. So as water and land use intensify, there are greater risks of environmental issues, undoubtedly. This brings to the fore the issue of maintaining the social license of farming. And failure to be proactive about it can lead to conflict and adverse consequences, which we have the advantage of observing what's happening in the Murray-Darling. At the same time, the number of players has increased, and water arrangements are becoming increasingly more complex. The role of government, one could say, is evolving. there's new capabilities available in terms of data and communication networks, which perhaps allows responsibility to be more dispersed, shared between players. Basically, we believe there is a strong incentive for collaborative governance in Tasmania, and that is a research focus for us. So on that note, I'll hand over to Ted. Thank you.
Thanks, Deepa. So to take up Deepa's point, in the middle of that diagram is a very strong incentive to collaborate. So the growth in demand and the growing uncertainty in supply, in fact, are an imperative to collaborate. So let's just have a look at what that actually means for Tasmania. The last couple of decades has shown two major trends in the climate drivers in Tasmania. This work comes out of Climate Futures for Tasmania, a project out of the Antarctic and Climate Ecosystem, CRC. It produced the finest scale regional forecasts of just about anywhere in the world at the time it came out, and it served Tasmania very well, and it gives us some insight as to what we might expect. So the westerlies moving down to the south and tending to miss the bottom of Tasmania, decreasing the summer rainfall, and increasing sea surface temperatures off the east coast, increasing autumn rainfall in some seasons. If you look at their projection for the whole state over the century, you'd be forgiven for thinking, well, you know, that's not too dramatic. There's a lot of white in there, a bit of yellow, it's not too bad. The Central Highlands looks a bit rough. But the story in their work is not in the mean, it's in the variance. And if you look at the seasonal, there we go. If we look at the seasonal record, we get a very different picture. A decrease of up to 18% in summer rainfall in the west, increase in about 20% in the winter, and that naturally translates into runoff, a decrease across the north in summer and autumn, increase in the east coast, and that inevitably translates into river flow. And if we look at one particular river in this example, and this is the Ringarooma, it's exactly what Bureau of Meteorology and the Climate Futures Project has been suggesting, that we're tending to see bigger troughs and slightly bigger peaks. And that presents a real challenge in terms of managing water availability and water security. There are two particular upsides to climate change, though. There's a conversation going on in Hydro Tasmania at the moment to say, well, look, if the cost of alternative energy, wind power, solar and storage, battery storage, keeps falling at the rate it has over the last 2 decades, they're going to be more in the water business than the power business, which is a very promising prospect for Tasmania. Another one, and this is some work out of David Phelan's master's thesis, all 6 global climate models show increasing pasture yields, and you can see the image on the right with irrigation, the increase not only in yield but in a decrease in the uncertainty of yield. So it's not all a downside, but that increased variability presents challenges. And one of the challenges is adapting, and adaptation varies depending on our scale of consideration. At the paddock scale, it's about improving water use efficiency. At the farm scale, it's about profit. It's about reducing the energy cost, the cost of moving water around. At catchment scale, it's about security of supply and managing water quality. And if we go to higher scales, if we look at industry and the state's exports, there's a growing demand by consumers for more information. You've probably heard of carbon footprinting. Something that's coming quite soon is water footprinting. Litres of water consumed per unit of product produced. Unilever is already doing that across their whole supply chain, and it's being demanded by consumers. So at each level of consideration within agriculture, within the food supply system, there are pressures to adapt. There's different sorts of information to support each of those decisions. Behind those, huge amounts of data. And what we're already seeing is a confusion of technology and data that's available. And if we just look at some of that, in the course of this year, 3 new companies have appeared in Tasmania offering data services at farm and paddock scales. And so this really raises a question about what's TIA's role in this. I think TIA has a fundamental role, as in collaboration with other parts of the university, especially ICT, in evaluating and navigating this burgeoning field of data. And a very good example of that is the Water for Profit project, which is based on peer-to-peer learning. So this is a collaboration between TIA, the Department of Primary Industries, TFGA and Macquarie Franklin. And so far, 54 farm businesses have been through this process. And it's really a case of learning what's the minimum set of data that I need to make the best decisions. It's very practically orientated, and I think it charts the way for an important role for TIA in evaluating and navigating this growing area. But if we consider that challenge of adapting at all those scales, there's a gap in the middle. At the micro scale, at paddock and farm scale, there's a lot of commercial offerings out there in terms of data services. At the national and regional scale, we've got the Bureau of Meteorology, which took over responsibility for managing Australia's water data as part of the National Water Initiative, and that's increasingly offering more and more information. But where there's a gap is at the catchment scale, and this is where it'll be critical to manage water security, and it brings us back to Deepa's point about the need for collaboration and the opportunities for collaboration. So a few years ago, as a result of a conversation between Jan Davis at TFGA and Ros Harvey from the university's Sense-T project, in partnership with DPI and CSIRO, they decided to try a little experiment. If we provided more up-to-date data, higher quality data to irrigators about water supply within their catchment, would it influence their water use and their water management? And the idea was to set up a platform to put stream flow sensors in the stream and make that available at near real time to a group of about 30 active irrigators. Now, the interesting thing was only 2 of the 30 irrigators ever went to the website, and only 1 of them went consistently. But what he did was SMS all the others. And the result of that was they started to collaborate, and they started to coordinate their extraction and release of water. And because I can't read all the way up the back, but you can probably read, the result was that they avoided a cease to take in a low flow year, and they saved, and this was a work done by AK Consulting, went and interviewed a number of those farmers and estimated a saving of about $1.5 million across those 30 growers in that season. The important thing about this was the growers had access to the same information as the regional water manager. It helped to strengthen their relationship. It wasn't a case of getting an SMS out of the blue saying you've breached the cease to take. They were very much involved in the condition of their river, and they're determined to manage it, and they nursed it through that season. We went to them at the end of that little experiment and said, what would you like to do next? And the challenge they put to us is, well, we don't necessarily trust all the people upstream, particularly the foresters. So if you can get the foresters involved, and in fact growers up and down the catchment, we think there's benefit in all of us knowing what's going on, in improving our situational awareness and our understanding. So the concept is to extend that data service so that different individual businesses would get 1 or 2 key parameters, and when they're happy with them and they're confident, they will then share them to others. In some cases de-identified if they're commercially in confidence, but to increase the general understanding of what's happening over a whole catchment scale. Soil moisture in different parts, stream flow, turbidity, even fuel moisture in the upper reaches for controlled burns. And that resulted in putting together this collaboration of about 9 partners, and we're anxiously waiting to hear the outcome, which we were told would be announced before the end of June, so they haven't got long. But what we're doing here is more than just seeing if we can extend that example in the Ringarooma catchment. We're also testing some ideas that came out of some work by an economist called Eleanor Ostrom. As a student, she heard the expression, the tragedy of the commons, which is the belief that any natural resource managed in common would inevitably be degraded. And she wondered if that was really the case. And with her students, she went out and studied 80 case studies in traditional and contemporary societies, and she came to the conclusion that it wasn't necessarily the case if you could meet these conditions. Now, you might say, that's a big ask. But what she showed was the conditions under which that could be met. Now, some of them are geographic that we have very little influence over. We can't influence topography, soil type, climate. But what can be influenced by the availability of better information are those ones highlighted in purple. So what we're really doing is testing Ostrom's idea that providing better information, allowing leadership and entrepreneurship to flourish, and by having a better understanding of what the rules and sanctions are and the consequences, and especially using the same principle as water for profit, the peer-to-peer learning, that there's an opportunity there to share the burden and share the load of water management at that scale. The year that her results were published after nearly a lifetime's work, 2009, Eleanor Ostrom became the first woman to win the Nobel Prize in Economics. So when you hear people talk about the tragedy of the commons, it can still occur, but it's not inevitable. And that is really what we're interested in testing. And we think that has application far wider than just Tasmanian catchments, which is why part of our interest in this area is to focus on these local issues of national importance, but to connect to international groups around the world that are working on these issues, on collaborative water governance, sustainable intensification, and social licence. Thank you very much.
Questions? No questions. I have a question. This is an odd question. It was the one I wanted to ask, and I might have even asked Deepa. We talk about water governance, and we talk about management of water. And not very long ago, we saw an extraordinary sight of $100 million of flood damage crashing through Hobart. Could Tia have done anything about that? Could you have known in advance? What could have happened to make that a different outcome? Or is that just an act of nature that we have to live with?
Maybe a bit of geographical awareness would have helped. The university is sitting on a gully called Rifle Range Creek, and it was piped underneath Dobson Road. And maybe we'd learn not to put supercomputers in basements and libraries in basements. But situational awareness, there's a series of gullies, and the university has to sit on a gully and part of a ridge. It's a great one for geography students, I think. Find out how that could never happen again.